Welcome class to lesson 810. In this video, we're going to go over the reading strategies and a worksheet on solving nonlinear systems. We'll be given one quadratic equation and one linear equation, and we will find where they intersect by both graphing and by using the substitution method. Just look at the first example here. We have a quadratic equation, y equals x squared plus 2x minus 3, and we have a linear equation, y equals 2x minus 2. To explain the graphing, we can just look over here to the right. And to graph it, we first found the axis of symmetry. X equals negative b over 2a. Now, once we find the axis of symmetry, we'll plug that point in to find the vertex. And then we could find a couple extra points and just kind of mirror it across the line of symmetry. For more information, we could always look at there's another video on lesson 810 as well, where we go over in detail graphing a quadratic function using this method. Oops, let me get rid of this here. Okay. Now, as far as graphing a linear equation, which is this equation up here, y equals 2x minus 2. We have it down here. We always identify the y-intercept first, and then we count the slope from that point. And that's what we did. We found the y-intercept was negative 2, which is right here. And the slope, of course, is a whole number of 2, and we'll just put it over 1. So it's going to be up 2 over 1, and then up 2 again and over 1. And here we have the 2 points of intersection, which are the solutions to the nonlinear system. Now let's look at the homework. It says to complete the following. Number 1, to graph a quadratic function, first locate the what of what. What should we always find when we're trying to graph a quadratic function? The first thing is always the axis of symmetry. Now to graph a linear equation, always find the y-intercept first. The reason why we find the y-intercept first is that that is a point. If you find the slope first, you can't graph a slope. A slope is like an angle measured from a point. So we need the y-intercept first as the point, and then we can count the slope from that point. So we'll find the y-intercept and the slope. Let's look at number 2. Solve the system by graphing. So we have a quadratic equation, and we have a linear equation. And I think graphing the linear would be easier first. So let's start with that. We're going to first identify the y-intercept, which is negative 3, and the slope, which is 1. So we'll graph the y-intercept and then the slope. We'll draw a little xy graph here. Let's graph the y-intercept of negative 3. Here we go. And then we're going to count the slope of 1. Of course, the slope, that means it's 1 over 1. So we're going to go up 1 over 1. So there's a dot. Then we go up 1 over 1 again. Up 1 over 1, up 1 over 1. Of course, we can reverse the direction as well. Whoops. There we go. Let me see. I don't know if I can delete that other stuff without deleting the graphs. We'll just leave it. Now we're going to solve for graph the quadratic formula. We first find the axis of symmetry. Negative b, so it's a negative 1 over 2 times a, and a is 1. So it's a positive 1/2. Now we're going to plug 1/2 in for x and find the y value. We know it's going to be 1/2 squared minus 1/2 minus 6. 1/2 squared is 1/4 minus 1/2 minus 6. Now 1/4 minus 1/2 is a minus 1/4 once we get a common denominator. And then it's minus 1/4 minus 6. So it's minus 6 and 1/4. Let's plug in a few more points. We'll plug in 1. We always want to plug in points close to the axis of symmetry. If you plug in 1, we get 1 squared minus 1, which is 0. And then 0 minus 6 is minus 6. Plug in 2. 2 squared is 4. 4 minus 2 is 2. 2 minus 6 is minus 4. And let's do another point, 3. 3 squared is 9. 9 minus 3 is 6. 6 minus 6 is 0. Let's see how these points look. So we're going to have x equals 1/2 as the axis of symmetry. The vertex is at 1/2 comma negative 6 1/4. 1, 2, 3, 4, 5, 6. That's about right here. If we plug in 1, we're going to have negative 6, which is about right there. Sorry, right here. If we plug in 2, we'll get negative 4. 1, 2, 3, 4. If we plug in 3, we'll get 0, which is right here. And we have our first point of intersection. So I know the graph is going to cross right there. Now let's graph a few more points on the mirror image. So I'm going to go ahead and plug in 0. We know we'll get minus 6, which is, actually, it's not going to be hitting that line yet. And actually here, let me use a ruler here so you can see if we can graph this a little better than what we have right now. There we go. So 0 and negative 6 is about right there. Let's plug in negative 1. Negative 1. Negative 1 squared is 1. 1 minus 1 is 0. Let's see. Excuse me. Minus 1 squared is 1. 1 minus a minus 1 is plus 1. So we're going to have 1 plus 1 is 2. 2 minus 6 is negative 4. So we already found our point of intersection. It's going to be at negative 1, negative 4. So we have our solution now. It's going to be at 3, 0, and at negative 1, negative 4. Now, if we ever go too fast in the video, just pause it and just continue that same problem again when you are ready. Now let's look at number 1 here. It says it's solved by graphing again. So I always like to graph the linear equation first and then the y-intercept. The linear equation has a slope of 5 over 1 and a y-intercept of negative 8. Now negative 8 looks like it's going to be off the graph. Yes. So we can try another point. Maybe in this case, maybe we'll make a little table here. We'll just plug in for x. We know if we plug in 0, we get negative 8, which is off the graph. Let's plug in 1. 5 minus 8 is going to be a negative 3. And we can plug in 2. 5 times 2 is 10. 10 minus 8 is 2. So let's do 1, negative 3, and 2, 2. There we go. And with 2 points, we can draw a line. Now let's go ahead and try the quadratic. I'm going to erase the work here. We're going to try the quadratic now. Now the quadratic is x squared minus 2, which means it's really x squared plus 0x minus 2. Let's find the axis of symmetry first. The b value is 0. And 0 over another number, of course, is just 0. Make a little xy table. If we plug in 0 for x, we're going to get minus 2. So that's going to be the vertex. And we can plug in another point. Let's plug in 1. 1 squared minus 2. We're going to plug in the 1 where the x is. 1 squared minus 2 is negative 1. If we plug in 2, 2 squared is 4. 4 minus 2 is 2. So we know, let me graph the axis of symmetry, which is going to be which is x equals 0, which is along the y-axis. The vertex is at 0, negative 2. Maybe I should switch colors here so it's easier to see. The next point is 1, negative 1, which still hasn't touched the line yet. We're still not haven't intersected yet. And the next point is 2, 2. Aha. Now this one, of course, will have a mirror image, and it'll look something like this. And this one's only going to have one solution here, the way it's drawn. I can only touch at one point, and that'll be at 2, 2. So this one only has one solution, 2, 2. Let's look at number 2 here. Graph the linear equation first. So we have a slope of -1/1 and a b value of +4. So the y-intercept is a +4, which is right here. And the slope is -1, which is down 1/1. And then, of course, down 1/1. So there's our line. And next, I'll go and change the color. We can do the quadratic. Let's find the axis of symmetry first. -b/2a. So -4 over 2 times 1. 4/2 is 2. Oh, that's a really bad line. See? So we have x equals 2 as the axis of symmetry. If we plug 2 back in, we can get the y coordinate. So 2 squared minus 4 times 2 plus 6. 2 squared is 4. 4 minus 8 is -4. -4 plus 6 is 2. So 2, 2. So there, we have one solution already at 2, 2. Let's plug in a point close. I know I don't want to, this graph is going to be opening up. If I plug in 3, it's not going to cross the line. So let's try a point next to 2, but on the left side. So I'll plug in 1. 1 squared minus 4 is -3. -3 plus 6 is +3. So 1, 3. So it looks like we already have the second point of intersection already. So, of course, that means there will be a mirror image right here. We can plug in one more point. Let's plug in 0. And this will get 0, 6 as a point, which is 1, 2, 3, 4, 5, 6. It's going to be something like this. So here's the graph. And it did cross at 2 points, here and here. So the answer here will be 2, 2. And we have an answer at 1, 3. Number 3, now we're solving by substitution. Remember, we're always going to always start off when it's y equals and y equals. We can just set y equal to y. The two equations equal to each other. And these are going to be factoring problems. I'm going to go ahead and move the x over to this side. And of course, we're going to subtract 3 over here as well. So we're going to get x squared plus x. If we subtract 3, we'll get -6. And now it's equal to 0. And now we have to factor it. We have to find the factors that multiply the -6, but they sum to 1. They sum to 1, but they're factors of -6. And we can try 3 and 2. 3 and 2. Maybe an x plus 3 and an x minus 2. Now if we solve, we're going to get x equals -3. And we get x equals +2. And we want xy coordinates here. So we're going to have to plug in -3 actually into both equations, make sure we get the same y value. So let's plug in -3. I'll first plug it into the top equation. -3 squared is 9. 9 minus 3 is 6. Now we have to plug in the -3 here next, and we should get the same value. And a -3 is a +3. 3 plus 3 is 6. So this point is good. This is a solution. Now let's try 2 into both equations. Plug in 2 here. 2 squared is 4. 4 minus 3 is 1. Let's plug in 2 here. -2 plus 3 is also 1. So 2, 1 is also a solution. So both points, -3, 6, and 2, 1, are solutions. Now let's look at number 4. We're going to set again y equal to y. So we have x squared minus 2x minus 3 is equal to minus 2x minus 5. Now we're going to move everything over to the right again. So we'll get x squared. If we add a 2x to a negative 2x, we'll get a 0x. And we're going to add 5 to both sides, and we'll get a plus 2 equal to 0. Now, if we solve for x, because there's no, all the x's here canceled. If we solve for x squared, we have to use a square root method. I'm actually going to move the 2 back over, because we can't factor when it's just an x squared. So we have x squared equal to negative 2. Now, how do we solve for x? We can use the square root method. We'll take the square root of both sides. Now, what's the square root of a negative? It is imaginary. So this means there is no solution. These two graphs may look something like this, where they will not intersect. So this one is a no solution. You go over here. Let's look at number 5. Now this one we have not yet solved for y. So we're going to add the 3x to the other side plus 1. Now we can do y equals y. So we have 2x squared plus x minus 3 is equal to 3x plus 1. We're going to move everything over to the right again. So we have 2x squared minus 2x, because we're going to subtract the 3x from the x, and we subtract 1, so we get minus 4, equal to 0. I'm going to erase some of the work here so we can write above it. Now, we should always simplify when possible. We could divide everything by 2, and we'll get x squared minus x minus 2 still equal to 0. And now we're going to factor this problem. 2 factors that multiply the negative 2, but they sum to negative 1. Well, we could do negative 2 and 1. So let's try x minus 2 and x plus 1. When we solve, we get x is equal to 2 and x is equal to negative 1. We now have to plug it back in and see what values we're going to get. If we plug in 2 here for x, we get 2 times 2 squared is 8. 8 plus 2 is 10. 10 minus 3 is 7. Now we have to plug in the 2 back into here. I actually erased it, but we had y is equal to 3x plus 1. So we'll plug the 2 in here. Now 6 plus 1 is 7. So this checks. The other point is x equals negative 1. If we plug in negative 1 again, back to here. 2 times negative 1 squared is 2. 2 plus a negative 1 is 1. Negative 1 minus 3 is negative 4. I think we do that correctly here. 2 minus 1 is 1. 1 minus, yeah, negative 4. Now if we plug in negative 1 here. Oh, I think there's a mistake here. Oh, whoops, there is an error here. It was minus 2. Sorry, we have to fix that there. There was a little mistake there at minus 2 here. Because when I plugged in, we got minus 4, and there was a little bit of a mistake here. So it's actually minus 1, minus 2. Now let's look at number 6. Oh, and the solutions, of course, yeah, you can see it on the screen, 2, 7, and negative 1, negative 2. And they both check now. Now, for number 6, again, y equals y. So we'll just set x squared minus 25 is equal to x plus 5. We'll move the x over and the 5 over. So we get x squared minus x minus 30 equal to 0. Factors of negative 30 that sum to negative 1. Factors of 30 include 15 and 2, 10 and 3, and 5 and 6. If we have a negative 6 and a positive 5, that should work. And we solve. We get x equals 6 and x equals negative 5. So let's plug 6 back in. Plug in the 6 here first. we get 36 minus 25 is 11. Plug in 6 here, you will also get 11. Now let's plug in negative 5. Negative 5 here gives us 0, and a negative 5 here gives us 0. So those are the two solutions, 6, 11, and negative 5, 0. Now, it says here solve by elimination. We won't use elimination when you have a quadratic and a linear equation. It's a lot of extra work. A substitution makes far more sense. So we'll just stick with our substitution method. Here we're going to solve for y. Divide everything by both sides by negative 1, and we get y equals 2x plus 2. We can now do y equals y. So we have 2x plus 2 is equal to the other y, which is x squared minus 1. I'll move this time everything to the right side. So we have x squared minus 2x, and we're going to subtract the 2, and we'll get a minus 3. So we need factors of negative 3 that sum to negative 2. Well, we could try negative 3 and positive 1. That should work. And it does. So we get x is equal to 3, and x is equal to negative 1. Now we have to plug these points back in to get the actual coordinates. So if we plug in 3, we can plug in the 3 right here. 3 squared minus 1 is 8. And we have to check it over here. Oh, I shouldn't have erased that. We had y is equal to 2x plus 2, which is this y from up here. Now we're going to plug in the 3 for the x again, and we'll get 3 comma 8. So these do check. That first point checks. 3 comma 8 is one solution. Now let's find the other solution. We're going to find negative 1. Negative 1 squared minus 1 is 0. If we plug in negative 1 to the other, we also get 0. So negative 1, 0 is the other solution. Now over here, we're going to have to solve for y again. Divide by negative 1, and we get x plus 1. We would do y equals y. So x plus 1 is equal to x squared plus 4x plus 3. Subtract the 1 over here and the x over here. So we'll get x squared. If we subtract the x from 4x, we'll get 3x. If we subtract the 1 from 3, we'll get a plus 2. Factors of 2 that sum to 3 could be 1 and 2. So x plus 2, x plus 1 equal to 0. If we solve, we get x equals negative 2 and x equals negative 1. Now, of course, we're going to plug these points back in. We got to get the y coordinate. So if we plug in negative 2, if we plug it in here and here, we'll get negative 2 squared plus 4 times minus 2 plus 3. So we'll get 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Of course, we have to plug also the negative 2 here, and we get the same answer. Now we're going to plug in negative 1 for x and find the y. Plug the negative 1 here and negative 1 here, and we'll get 0. And if we plug the negative 1 here, we also get 0. So the solutions are correct. Negative 2, negative 1 is a point, and negative 1, 0 is a solution. Number 9. We'll first solve for y. Now we will do y equals y. So we have minus 6x minus 13 equal to the other y, 2x squared plus 4x minus 1. I'll move this over here and subtract this from here. So we have 2x squared. We're going to add the 6x to the 4x to get 10x, and we're going to add the 13 to the negative 1 to get 12. Now we could divide everything by 2, just to make it a little simpler. Okay, we just now have to factor this quadratic. Factors of 6 that sum to 5 will be 3 and 2. We have x plus 3 and x plus 2 equal to 0. When we solve, of course, we get x equals negative 3 and x equals negative 2. We'd have to plug in negative 3 where the x is and find the y value. If If we plug in -3 here and here, 2 times -3 squared is 18. 18 plus 4 times -3, that's 18 minus 12, which is 6. 6 minus 1 is 5. Now let's plug the -3 here. 18 minus 13 is 5. So that checks. Now we have to check x equals -2. Or I should say we should plug in x equals -2 and find the y, and then we do the check. If we plug in -2 into the quadratic, 2 times -2 squared plus 4 times -2 minus 1. 2 times a -2 squared is going to be 8. 8 minus 8 is 0. 0 minus 1 is minus 1. Now let's plug in the -2 into the linear equation. 12 minus 13 is minus 1. So they both check. Now let's look at number 10. Get the first solve for y for the linear equation. Divide both sides by -1, and we get y equals 2x minus 5. Of course, now we do, for the last problem, the y substitution as always, y equals y. I will write minus x squared plus 3x minus 3 is equal to 2x minus 5. I'll bring this over, and I'll bring the 5 over here. We get minus x squared. Now 3x minus 2x is x. Minus 3 plus 5 is 2. Now we have a little problem here. I have a negative x squared because I brought everything to the left side. So I'll multiply everything by -1. I can now flip all the signs. X squared minus x minus 2 equal to 0. We now factor the equation. Factors of -2, that sum to -1. Well, -2 and +1 work. X minus 2, x plus 1. Now when we solve for x, we get x equals 2, and x is equal to -1. We'll plug 2. I'll plug 2 up here into the quadratic first for the x's. -2 squared is -4. -4 plus 6 is going to be 2. 2 minus 3 is -1. Now we'll plug the 2 in right here. 4 minus 5 is -1. It checks. Now let's plug in the other x value, which is x equals -1. If I plug it back into the quadratic, a -1 squared is a -1. -1 minus 3 is a -4. -4 minus 3 is a -7. I'm just kind of doing this all, just kind of do some mental math here. Now we're going to plug in, let me erase here a second. We're going to plug in the -1 to the linear equation. 2 times -1 is -2. -2 minus 5 is -7. So those are the two solutions. 2 -1 and -1 -7. And now this concludes the lesson going over the reading strategies and the A worksheet.